Good morning, class. We are looking at Chapter 8, Analytic Geometry. Here's 8.1 Ellipses. So we've looked at the circles. Now we are looking at the ellipse. Number one, the objectives are, number one, determine general and standard form of equation of the ellipse, graph ellipses with centers at the origin, solve applied problems. So recall we looked at circles. A circle is a set of points in a plane that are the same distance, called the radius, from a fixed point called the center. Circle with its center at the origin and radius r has the formula x squared plus y squared equals r squared. It follows the distance formula or Pythagorean theorem. This distance is x, this distance is y, and x squared, a squared plus b squared equals c squared, so x squared plus y squared equals r squared. Or you can say this is 0, 0, this is x, y. You want to find the distance between these 2 points and then square it. That's the standard form for a circle centered at 0, 0. Circle with its center at h and k and radius r. If x and y is a point on the circle, then by the definition of a circle and the distance formula, it follows that r is the square root of x minus h quantity squared plus y minus k quantity squared. Squaring both sides gives the equation of a circle in standard form, which is x minus h quantity squared plus y minus k quantity squared equals r squared. So basically find the distance between these two. And remember, the distance is fixed and it's equal to r. And this is how you come up with a circle. If you cut this cone with a plane perpendicular to its axis, it creates a circle. And now the ellipse. An ellipse is a set of points in a plane, the sum of whose distances from two fixed points is a constant. The two fixed points are called the foci. Each is a focus of the ellipse. F1 and F2 represent the two foci of an ellipse. So if you pick any point and connect it to F1 and then F2, the sum of these two is the same. That is the definition. The formula is, when the center is located at 0, 0, x squared over a squared plus y squared over b squared equals 1. The standard form of an ellipse with its center at the origin. The x-intercepts a0 and minus a0. The y-intercepts 0, b, 0, negative b. And if a squared is larger than b squared, which means a is larger than b, the major axis is along the x-axis. And so these 2 points, the x-intercepts are also called vertices. If it's the other way around, if b squared is larger than a squared, the major axis is along the y-axis. B squared plus c squared equals a squared. An ellipse may be along the x or y-axis or none of the above. The side that is elongated is the major axis, and the other side is called minor axis. And if it's centered at h and k, the formula becomes x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. It's important to understand circle is a special case of an ellipse where F1 and F2 come together and becomes the center, or A is equal to B. The graph of an ellipse is not that of a function. Clearly, it fails a vertical VLT, vertical line test. The foci lie on the major axis. The line from V to V prime, okay? And the minor axis is B to B prime. So the elongated side gives us the major axis. Sometimes we call this FF prime, sometimes we call it F1, F2. Either way, this distance plus this distance plus this distance, or if you pick any other point here and connect it, makes no difference. That is fixed. Now, let the foci, which is the plural for focus of an ellipse, be at the point plus minus C and 0. So C0 minus C0, or over here, C0 minus C0. The sum of the distances from the foci to a point x comma y. So P has coordinates x comma y, or if you look at this one, the ellipse is 2a, y is that. We want to look at that concept. First of all, please understand any point. This point, first of all, P has coordinates x comma y. So the distance from P to F and the distance from P to F prime, if we add them up, it's fixed. And we want to prove that it's 2a. But remember, if that point is here, that means B, if you connect it to F and F prime, BF and BF prime is the same thing. This distance is the same thing. Pick up any point, connect them. The sum of these two distances is the same thing. Another point that you can look at would be this point. So VF plus VF prime, which is the same as VF plus FV prime by symmetry. Remember, this is symmetric with respect to the X and the Y axis. So this distance is the same as this distance. So you notice this distance is C, this distance is also, the distance is C when we go from negative C, comma 0 to 0, 0, or from 0, 0 to C, comma 0, this distance is the same as this one. So VF plus FV prime, which makes it V prime. And if this is A, and so is this, so VV prime is 2A. That's the proof. Also, if we pick this point, the y-intercept, and we look at this distance and this distance. So BF and BF prime, you can look at this one if you want. Doesn't make any difference. This point is BF plus BF prime, or BF1 plus BF2. It's the same thing. That is also 2A. Why? By definition of an ellipse. And by symmetry, these two are the same. So BF is the same as BF prime, which makes it A. So if these two are identical and their sum is 2A, each one must be A. And now if you look at this right triangle, Pythagorean identity says this side squared plus this side squared is this side squared. So B squared, C squared, they add up to A squared. So please don't mix them up with the basic Pythagorean theorem, normally we say a squared plus b squared equals c squared. The largest side, in this case, because it's elongated along the x-axis, the largest side among A, B, C would be A. We have A, we have B, and we have C. If it's elongated along the x-axis, A is larger. If it's elongated along the y-axis, B is larger. All right. Let's look at the proof quickly. And having the distance formula as follows. Remember, the distance formula is x up to minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. I'm going to prove this. So we are going to pick a point and look at the distance from this point and the distance from this point and add them up. So this has coordinates x comma y. This has coordinates c comma 0. According to this formula, the distance from P to F is x minus c quantity squared plus y minus 0 quantity squared. So this distance is this one. Now this distance, let's use a different color on that. What do we have here? PF prime. X minus negative c, which makes it plus c quantity squared, and y minus 0 quantity squared. So that's what we have. So x minus negative c makes it x plus c quantity squared plus y squared under the radical. And we know that the sum of these two is fixed. That's the definition of an ellipse. And what is that equal to? 2a. So the sum of these two, when we add them up, these two, we get 2a. To solve this, we are going, when you want to solve an equality that involves two square roots, you move one of them. Let's say we move this one. Now we're going to square both sides. You're not responsible for the proof, but it would be nice if you could follow. When you square this, it comes out as x minus c quantity squared plus y squared. When you square the right side, this gives you 4a squared minus this times 2 times this. So minus 4a times the square root plus this comes out. So take a look. This basically comes out. 2a becomes 4a squared. 2 times the product of these two, and then this comes out. Now we are going to square this. We're going to square this and see what happens. Quickly, x squared minus 2cx plus c squared. This remains, this remains, this remains. X squared plus 2cx or 2xc plus c squared plus y squared. We don't move things around. X squared identical, we drop them from both sides. C squared and y squared identical, we drop them from both sides. Now, if I move this one to the right, I can add it to this one, make it plus 4cx. If I move this to the left, the sign becomes positive. So this moves, becomes positive. This moves, becomes positive with this, adds up to 4. We can divide both sides by 4. And now we are going to Raise it to the power of 2 again. This gives you a squared, and this comes out. This gives you a to the power of 4 plus 2 times this 2, which is 2a squared cx, or 2ca squared x, however you want to mention it, and this is c squared x squared. So raise both sides to the second power. Remember x plus c squared, we've already done that, okay? And this is x squared plus 2cx plus c squared. We're going to multiply the a squared by it. We get a squared x squared plus 2ca squared x plus a squared c squared. And then a squared y squared. So basically raise this to the power of 2, which is this one, and multiplied by a squared. So let's move things around. We're going to keep this one. We're going to move this one. These two are identical. We drop them from both sides. And we move this. So it looks like this. Everybody take a look. So we get a squared x squared minus c squared x squared plus a squared y squared. The right side has a to the power of 4. This moves, becomes minus a squared c squared. And over here, we can factor out the x squared. We get x squared times a squared minus c squared. Over here, we can factor out a squared. We get a squared times a squared minus c squared. And so we divide by the right side. So divide everything by this. Divide by the right side. So the right side becomes 1. Divide by this. This is a number. When you divide by this, this one gets x squared divided by a squared. This one gets y squared divided by a squared minus c squared. So we are dividing by the right side, everybody. And we remember b squared plus c squared equals a squared. Which means a squared minus c squared is b squared. So this means a squared minus c squared is b squared. This is the formula if a is larger than b, larger than 0. You're not responsible for the proof. If you could follow it, that'd be fantastic. So we said x squared over a squared plus y squared over b squared equals 1, b squared plus c squared equals a squared, and we are assuming a is larger than b, of course. This ellipse has vertices at plus minus a comma 0, endpoints of the minor axis 0, plus minus b, and foci plus minus c 0, where c squared is a squared minus b squared. Horizontal major axis c squared equals a squared minus b squared. So basically when a is larger than b. what happens here is, as you can see, it's elongated along the y-axis. And it's important to know, in some texts, they like to change the location of a and b. I rather write it as x squared over a squared and y squared over b squared. So I keep the a under x. So this is still a0 minus a0, 0b, 0 minus b, but this is the major axis, which means the foci are along that as well. The ellipse with center at the origin, an equation x squared over a squared plus y squared over b squared. A squared plus c squared equals b squared because b is larger than a, larger than 0. Just remember, a, just remember this. When you have a, b, and c, you follow Pythagorean theorem, just pick the one that is the largest as the hypotenuse. In this case, a is the largest. In this case, b is the largest. So b is larger than a, larger than 0, has vertices at 0 plus minus b. Endpoints of, so the vertices are that. Endpoints of the minor axis are at the x-intercepts plus minus a and 0, and foci at 0 plus minus c, where c squared equals b squared minus a squared. Vertical major axis, c squared equals b squared minus a squared. This is the synopsis of what you need, everybody. So either elongated along the x-axis or the y-axis, the only thing really that matters. Foci are always along the major axis. So in this case, the foci are somewhere here. You have to calculate them, of course. Example 1, graph ellipse. Graph the ellipse and label the x and y intercepts. Find the area of the ellipse, x squared over 16 plus y squared over 4 equals 1. And we are going to use the general solution. So let's see what we need to do. It's important to know that 16 means 4 squared. If you don't want to write it, you don't have to, as long as you recognize that means a is 4 and b is 2. So this is 2 squared. I write that just to make sure, at least to get us started, we are comfortable with that. So the center is at 0, 0. A equals 4, therefore x-intercepts become the vertices at 4, 0, negative 4, 0. B equals 2, therefore the y-intercepts are at 0, 2, 0, negative 2. Put them together. That's the graph. The area, as you recall, the area for a circle is pi r squared. By the same token, the area for an ellipse becomes pi times AB. Please understand, when A is equal to B, we have a circle and we call it R. So just quickly, if A equals B, we have a circle, everybody. Okay. So pi times R, now pi times A times B. So pi times 4 times 2 is 8 pi. That's how you calculate. The circumference is 2 pi r for a circle. In this case, it's close to pi times a plus b. It's not identical. Finding an equation of an ellipse. Find an equation of the ellipse with the center at the origin, one focus at 3, 0, and a vertex at negative 4, 0. Graph the equation. All right. Let's see what's happening. The vertex, one of the vertices is at negative 4, 0. So that means the other one must be at 4, 0. That means A must be 4. The focus is at 3, 0. That means that C must be 3. So This tells us it's the vertex, everybody. Vertex says A must be 4, and focus says C must be 3. So that's very important to understand, everybody. All right. Now we go with this formula, b squared plus c squared equals a squared. Let me, b squared plus c squared equals a squared, which makes b squared plus 9 equals 16. Subtract 9, you get 7, and b is square root of 7. Again, it's pretty straightforward as to how we arrive at that. Everybody okay? So the formula x squared over a squared plus y squared over b squared equals 1 becomes x squared over 16 plus y squared over 7 equals 1. So that's the equation. So it's very easy to get the equation. The next one, we know the center is located at 0, 0. A equals 4. The x-intercepts are at 4, 0 and negative 4, 0. We want the y-intercepts. We know b is square root of 7. Almost 2.6 or so. So 0 square root of 7, 0 negative square root of 7, and roughly, as I said, 2.6 something, 2.7. And we have the graph. We have the center, we have the vertices, we have the y-intercepts along the minor axis, and we have the foci. If you were to graph it using a graphing calculator, you have to solve for y, and that gives you two pieces. One is positive square root of 7 times 1 minus x squared over 16, which is the top half. And one is the same thing with the negative in front of it that gives you the bottom half. That's extremely important to know because you put y1 equals that, y2 equals that, and it puts it together for you. Graph 4x squared plus 9y squared equals 36. Recognize this one as an ellipse. When we have both x and y having exponent 2, we have x squared and y squared, and their coefficients are different, but they have the same sign. That means they're both positive or negative. If they're on the same side, it's an ellipse. So to put it in a standard form, you're going to divide by the constant 36. So if I divide by 36, this becomes x squared over 9, this becomes y squared over 4, and this becomes 1. Because we want 1 on this side, that's why we divide by the constant. So that, obviously, the center is at 0, 0. A is 3, and B is 2. So A is 3. The x-intercepts that are also the vertices because A is larger than B. A is square root of 9, 3. B squared of 4, 2. So they're at 3, 0, negative 3, 0. It's not too squared, it's a little bit off. B is 2, the y-intercepts at 0, 2, 0, negative 2, and put them together. So we have those points. If they ask for the domain is from -3 to 3, and the endpoints are included. If they ask for the range, it goes from -2 to 2. To find the coordinates of the foci, remember Pythagorean theorem, c squared is a squared minus b squared, because a, this is elongated along the x-axis, a is larger than b, so a squared minus b squared. And 9 minus 4 is 5, so c is plus minus square root of 5, and therefore located at minus square root of 5, 0, square root of 5, 0. Those are the pairs. Roughly about 2.1 and negative 2.1. Now, as far as a calculator is concerned, you solve for y, and it gives you two answers. If you solve for y, it gives you plus minus the square root of 36 minus 4x squared over 9. Or 36 divided by 9 is 4. So you put y1 equals 4 minus 4x squared over 9, and to the power of 0.5. It gives you this half. If you put y sub 2 equals the same thing with the negative in front of it, it gives you the bottom half. Notice, since I have both of them, I have the top half. This is the top half. This is the bottom half. And when you graph it, it puts the two halves together, everybody. It puts the two halves together. It's very straightforward. Analyze the equation 9x squared plus y squared equals 9. Again, we notice we have x squared and y squared. They both have the coefficients are both positive, but different. That makes it an ellipse. Divide by the constant 9. This makes it x squared. This is y squared over 9. And remember, you don't have the denominator. The denominator is 1 here, so it makes a equals 1 and b equals square root of 9 or 3, just for the sake of argument. And so it's centered at 0, 0. A equals 1, which gives us the x-intercepts at 1, 0, negative 1, 0. B equals 3, which gives us not only the y-intercepts, also B is larger than 1. It makes it vertices. It makes it the major axis, 0, 3, and 0, negative 3. We want to find the coordinates of the foci, and in this case, class B, this distance is B, is larger than A. So C squared is B squared minus A squared, which makes it 9 minus 1 or 8. And C is plus minus the square root of 8, and you should know it's plus minus 2 square root of 2. And that means negative 2 square root of 2, 0, positive 2 square root of 2, 0. And if you graph it, the location is almost there. Remember, square root of 2 is about 1.42 times that. Makes it about 2.8. It's very close to 3. So that's the graph. And this graph has the center, the x-intercepts, the y-intercepts that are also the vertices V, 1 and 2. Okay, that's why, the vertices. And the location of the foci. The domain, if they ask, is from -1 to 1, and the range is from -3 to 3. So this is a typo, everybody. Let me fix that. So 1 to 1, and this is 3. Okay, just in case, making sure that it makes sense to everybody. All right. Now, graph ellipses with centers not at the origin, but rather at H and K, and ellipse centered at H and K, and either a horizontal or a vertical major axis satisfies the following equation: x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. This is the center, hk, and if this distance is a, it makes this h plus a, and makes this one a h minus a. The y coordinate remains as k, and that's the idea. We are assuming a is larger than b. The major axis is along the x-axis or parallel to the x-axis. In the formula, h shifts the graph left or right from the origin, and k shifts the graph up or down from the origin. In the case of a horizontal major axis, a is larger than b, and we have the same formula: c squared equals a squared minus b squared. In the case of a vertical major axis, then b is larger than a, and c squared equals b squared minus a squared. I like to keep the a squared under x minus h quantity squared, and b squared under y minus k squared, regardless of which one is larger. Again, in some texts, they like to change that. I think it's more confusing when we do that. So graph the ellipse with the center at h and k. Graph the ellipse, label the center and the points above and below, to the left and to the right of the center. Find the area, and we have x minus 2 squared over 25 plus y plus 3 squared over 16 equals 1. So let's see how we tackle this question, everybody. So as we compare this to this, we notice the center is located at +2, -3. So 2 to the right, 3 down, roughly. Sometimes it's a tad off. A squared is 25. It makes a equals 5. So this is a squared, everybody. A squared is 25. A equals 5. So in a matter of comparing to x-intercept, this is not going to give you x-intercept. So maybe I should actually cross this out. It's a matter of comparison. Rather, what it does, it gives you the idea of vertices, everybody. So the vertices, we go back to the center and we move it 5 units to the right, which makes it 7 minus 3, 5 units to the left, which makes it 2 minus 5, or -3, 3. So add and subtract 5 to the x coordinate. Now, B is 4. And so we go back to the center. We go 4 units up. That means X is still 2, -3, and B or 4 gives us +1. We go 4 units down, and it makes it -3 -4, which is -7. And again, it's in a matter of comparison to what we did as the bar intercepts. And the graph looks like that. As far as the area is pi AB, which makes it pi times 5 times 4, or 20 pi. We can calculate the foci. C squared is A squared minus B squared. 25 minus 16 is 9. So C becomes 3. So you can go 3 units to the right, 3 units to the left to find the foci. Okay. Graph the ellipse, label the center and the points above and below the left and the right of the center. So we're going to analyze this, and we quickly compare this to the general form, and we notice the center is located at -2, +1. A squared is 16, A is 4. And we go back to the center. We go 4 units to the right and 4 units to the left. If I want to go to the left, I'm going to subtract 4 from -2, I get -6, 1. If I want to go to the right, I add 4 to it, I get 2, 1. And here's the 2 points. B squared is 25. Maybe I should do this. So B is 5. So the vertices, because B equals 5, we go back to the center. We go 5 units up, makes a -2, 6. We go 5 units down, makes a -2, 1 minus 5, which is -4. We graph, and those are the pairs. And again, you can calculate the C squared. Now, because B is larger than A, is B squared minus A squared, which makes it 9. And again, C happened to be 3 again. But this time, from here, you go up 3 units, you go down 3 units. So you can calculate the C for this one as well easily. Analyze the equation. The equation is 4x squared plus y squared minus 8x plus 4y plus 4 equal to 0. What I want you to notice is this. Both x and y have degree 2. And both of them have coefficients that are having the same sign, namely positive. So that makes it an ellipse. You have to just put it in a standard form to see that. Therefore, here's the process. The process is completing the square. So first and foremost, we move the 4. Secondly, so here's what we do. We put these two together. We move this and we put these two together. That's the idea. These two, we can take the 4 out. Now, we need to add something. Let me show you for this one. B is -2. Divided by 2 is -1. Square root is +1. For this one, B is 4. Divided by 2 is 2. Square root is 4. So we need to add 1 for this one. So we add 1 to both sides. We need to add 4 for this one. We're going to add 4 to both sides. So we add 1 and 4. Now, when we add 1 here, that means 4 times 1. Please understand, you're adding 1 to add the same thing. Because there is a 4 in front, this 4 is because of that, and this 4 is because of that. These two cancel each other. So the right side is 4, and the left side is 4 times x minus 1 squared plus y plus 2 squared. What do? We divide by the constant, the right side, meaning we're going to divide by 4. Put it in standard form to make this one. So when you divide this one by 4, these two cancel each other. This remains. And remember, when they cancel each other, perhaps to make sure we see what's going on, we are going to write this as over 1. So we see that a squared is 1, and so is a. That's why maybe it's a good idea to write. So what do we notice? Right away, we notice the center is 1, -2. So as I mentioned, a is 1. So we go back to the center. And we go 1 unit to the left, 1 unit to the right. 1 unit to the left makes this 0. 1 unit to the right makes this 2. So again, 1 unit to the left, 1 unit to the right. To the left, 0 minus 2. To the right, 2 minus 2. And you put them there. B squared is 4. B is 2. B is 2, everybody. This is B squared. So now we have the vertices. We go back to the center, and B units up makes this 0, 1, 0. B units down makes this -4, 1 minus 4. Put them together. Okay, so those are the 4 points. To calculate the c squared, remember it's b squared minus a squared because b is larger than a, and that makes c square root of 3. The value of c is square root of 3. So from the center, we're gonna, here's the measure axis. From the center, we go up by square root of 3, which is about 1.7. and we go down by square root of 3, which is about 1.7. Again, you go down. So that means you add and subtract square root of 3 from the y coordinate. See, 1 doesn't change. The y coordinate up and down, and it results in the following. Now, that's very close to that. So it's 1. This one is 1, comma, -2 plus square root of 3. Again, this is 1.7. Roughly, this is -0.3, just to give you an idea. And this is roughly -3.7. 1 minus 2 minus 1. The others are pretty straightforward. A communication satellite travels, we are looking at an application, in an elliptical orbit around the Earth. The maximum distance from Earth is 25,000 miles, and the minimum distance is 24,500. Earth is at one focus of the ellipse. Find the distance from Earth to the other focus. So let's look at the situation, everybody. So here's the ellipse. A1, A2, the furthest from each other. Focus 1, focus 2. Earth is located at one of them. Let's say at F1, it doesn't matter which one. And the satellite is going around this elliptical orbit. The maximum distance from Earth. So this satellite has this distance, as it moves here, this distance, as it moves this distance, and so forth. What would be the maximum distance from the Earth when it's located here? So this distance is the maximum distance of F1, A2. So when it moves here, the maximum distance is F1, A2, and it's 25,000. As it moves, the closest distance when it's at A1, the closest distance is this. And by the way, this is not to scale. We just want to. So this distance is the minimum distance of 24,500. So F1A1 is the minimum distance of 24,500. Find the distance from Earth to the other focus. So we want F1, F2. So the difference between the two, F1, F2 is F1, A2 minus this distance. And this distance is the same as this distance, F1, A1. You can say F1, F2 is F1, A2 minus F2, A2, right? F2, A2. And F2, A2 is the same as F1, A1. So we're going to replace this one with F1, A1. This is 25K, this is 24.5K, and the difference is 500 miles. The Whispering Gallery in the Museum of Science and Industry in Chicago is 47.3 feet long. The distance from the center of the room to the foci, this is the foci. So we have this distance, A to minus A, this whole distance. So this is, in essence, this is 2A, everybody. foci. This distance is 20.3 feet. This distance is 20.3 feet. Find an equation that describes the shape of the room. How high is the room at its center? First, let me tell you about what's called a whispering gallery and how do we arrive at it. This is one of the properties of an ellipse. A whispering gallery is usually a circular, hemispherical, elliptical, or ellipsoidal enclosure, often beneath a dome or a vault, in which whispers can be heard clearly in other parts of the gallery. Sound waves bounce off the curved surface of the surrounding walls, converting from one focus to another in the elliptical shape. So you're standing here, you whisper, it hits the walls, and it focuses at the other foci. So focus 1 to focus 2. That's why it's not just anywhere. If you are at one of the foci or close to it, then somebody at the other focus can hear you. That's the idea. Consequently, even a faint whisper spoken at one focus becomes distinctly audible at another focus within the gallery. So again, what happens, the sound waves, if you're standing at one of those foci, let's say focus 1, and somebody's at focus 2, if you whisper, they can hear it because it concentrates back their sound waves. And they use that even for surgery, for example, to they put the laser here, and the one has a kidney stone, the kidney stone located here, and they send the shock waves through an elliptical, bathtub, and they break the stone, the kidney stone, as an example. So find an equation that describes the shape of the room. How high is the room at its center? First and foremost, we set it up such that it appears to have a 0, 0 at the center. So we follow x squared over a squared plus y squared over b squared equals 1. And it's important to know b is the height of the room. So this is located at 0b, okay? The height of the room at its center. And remember, this is 47.3. Okay, this is 0b, okay? And this is 47.3. The length. So A is half of that. If you divide it by 2, half of this gives you A. C is given as 20.3. We can calculate the B. How do we calculate the B? A squared minus B squared equals C squared, or you can say B squared is A squared minus C squared. So B squared is A squared minus C squared. 23.65 squared minus 20.3 squared. You put it into a calculator, you get the B squared, and you take a root, and about 12.1. The reason I go with 1 decimal to answer, first you use a lot of decimals in intermediate steps, finally with 1 decimal because everything has been given with 1 decimal. So if this is 12.1 feet, that means the B must be that. That means the height of the room must be that. What about the equation? X squared over A squared plus Y squared over B squared equals 1. So X squared over A, 23.65 squared. Y squared over, we have the B squared, 147.2325. You can square that, equals 1. And it looks like this. So this point, this is 25, but this point is 23.65. This one is negative 23.65. This is 0.12.1. And the focus at 20.30, negative 20.30. And this is the graph, the equation and the value for B. 12.1 feet.